In this video, we're looking at question 19 of the 2020 10A Test 3. So we have the competitors of a cross-country run are nearing the finish line from a lookout 100 metres above the track. It's quite high up. The angles of depression of the two leaders, Nathan and Rachel, or Rachel, are 40 degrees and 62 degrees. So 40 degrees, so that would be Nathan, and Rachel, 62 degrees. So that would be Rachel there. I'm not sure if that's needed, but let's just put it in. So, how far apart are the competitors to the nearest meter? X. Now, to work this out, probably the best thing to do is to recognize that there's two triangles. Okay. So we're going to assess both of these triangles and then just take the difference. Now, we always assume that posts are built by handymen who really can build a post, not to the, not slanted like leaning tower of Pisa. How far apart are the two competitors? Well, we've broken apart these triangles, and I'm just going to draw both of them here, not to scale obviously, and that's both 100 meters, and I'm going to call this point O because that's like the base, right? This is the top of the post, and then we've got N for Nathan and R for Rachel. Now we know here that this is 40 degrees and this is 62 degrees. Now, if you do remember your alternate angles, we know that this here, 40 degrees, will also be down here as well. So this bit here will also be 40 degrees. So if I continue this, can you see that Z, the alternate angle, because these are parallel, ground is parallel with the horizontal. So therefore this angle also will be 40 degrees. By that logic as well, if we kept that parallel, this is 62 degrees, therefore this will be 62 degrees. So let's put that onto our diagram, and now we have two triangles we want to solve, and each time we want to work out the base here. The difference will be, and I should use a different letter, let's use y and z. So y is equal to, and what we have here is we've got opposite and adjacent, so this would be a tangent, okay? So let's just put in our tangent formula. Tan 40 degrees is equal to opposite, which is 100 over y. Rearrange, y is equal to 100 divided by tan 40 degrees, okay? And let's do all our calculations at once. This one here is tan 62 degrees is equal to 100 on z. Rearrange, z is equal to 100 on tan 62. And now let's just do all of our calculations. So, shift divide for that nice little fraction line, and sorry the video is still just catching up there, on tan 40 degrees, close our bracket, and we get that distance there. So therefore, we can say Nathan is 119.17, or I should say 18 meters away. And let's see what Rachel is as well. Now we can just change this, right, now that we've typed that in, 62. So we can say Rachel is 53.17 meters away from the line. So what's the difference? We go 119.18 minus this answer here, so shift execute, and we've got the difference as the nearest meter, 66 meters. So the answer is A. On to the next question. We're on to question 20 now, and this is the last question of the test. A boy walks in a true bearing of 90 degrees and then 3 kilometers on a true bearing of 130. So I like with all these to start with a diagram. So here we go. And this here is going to represent his start point. So he starts here at the origin and he walks 2 kilometers on a true bearing of 90 degrees. So he walks in a true bearing to here, and that there is 2 kilometers on a bearing of 90 degrees. So 090, true bearing starts 000, 090, so he's basically heading east. Now, at our next point here, we draw another little compass bearing, okay, and then he walks on a true bearing for 3 kilometers of 130 degrees. Okay, so 130 degrees will look like this. Because we know that's going to be 90 degrees plus another 40, and this one's 3 kilometers. Okay, So I put 3 kilometers in there. And this here is 130 degrees. Now we've got our diagram. How far east is the starting point is the boy at the completion of his walk? Okay, so, well, east we know, if we draw our thing, never eat soggy Weet Bix. So we want to figure out how far east he went. So he goes 2 kilometers east, and then he goes a certain amount more. Okay, now this bit here, you may note, it was always helpful to zoom in on our diagram, is we want to figure out that east component. So in a red line, I'm just going to dash out, this is the extra east component he's gone. Okay, and it's just loading up there. So to work out that, I can establish a triangle, a right angle triangle, and we know that we can work out a bit more of that triangle. If this is 30 here and this is straight out, then we're left with, that's a 90-degree angle, and what's left in here would be a 40-degree angle. So effectively, and I'm going to try and do this in a different color, that angle there is going to be 40 degrees. So what we want to do is to figure out how far east he went. Is he went 2 k's plus the trig, and we have to do some trig to find out what this red dashed line here is. So I'm going to call that line x. Okay, so x is equal to, and let's have a look. Well, we need to establish x, we need to use a bit of trig. So let's rewrite this as, we've got cosine 40 degrees is equal to adjacent, which is x over 3. Therefore, x is equal to 3 times by cosine 40 degrees. So let's type that in, 3 times by cosine 40 degrees. And I've got a value of 2.30 meters. Okay, so to answer part A, let's zoom out a bit now. To answer part A, he went 2 kilometers plus another 2.30 kilometers, getting him a distance of 4.30 kilometers. Okay, and then I'll say east. Now it says 1 decimal place, so I better go 4.3 kilometers east. Okay, part B. How far south is the starting point is the boy at the completion of his walk? Well, let's have a look at our diagram again, and I'm going to zoom in just to make it a bit clearer. He started here, he went across 2 k's and then went diagonal at a bearing of 130 for 3 k's. So we can see that how far south did he go, and I'm going to highlight this in green. We can see he's here and he ends up that far south. Now that line there is the same length as this line here. So if we work out this line, we can figure out how far south he went. So I'm going to highlight that with a Y. Okay, so how can we work out Y? Well, this is 40 degrees here and this is 3 k's. So we can use sine. Okay, so I'm going to zoom back out now that we've established that. And we go, well, sine angle 40 degrees is equal to opposite y over 3. Therefore, y is equal to 3 times y sine 40 degrees. We'll plug that into a calculator. We go 3 sine 40 degrees, and we get an answer of y is equal to 1.9 kilometers. Therefore, it went 1.9 kilometers south. Okay. Now, to return directly to his starting point, how far must the boy walk and on what bearing? Okay, so this one is a little trickier. What we need to do is figure out how far, what bearing this will be here. Okay, now we've got that there, and I've drawn a dashed line directly connecting that. One thing you might note is that we've made this triangle here, and let me zoom in again. So what we want to figure out now is we want to establish, if we have that there, what is that bearing there? And call that, I guess, theta. So what's that bearing? So he has to spin all the way around till he's facing that way, and we need to figure out that distance. Now you may note something. Do you see the right angled triangle here? Aha. So 2 plus x, that's one side length, and then we've got y as the other side length. So that means we can firstly work out the distance, and let's call that z, by using Pythagoras' theorem. And let me zoom out again, a bit more, and in. There we go. So, C. We know that it's going to be, the first side length is 4.3 squared, which is how far he went east, so 4.3 squared, which is from part A, plus 1.9 squared, take the square root, will equal z. So let's plug that in. And you can actually use a square root function in your class pad. So let's put that in. 4.3 all squared plus 1.9 all squared equals 4.7 kilometers. So let's have a look. To run directly to his starting point, how far must the boy walk? Well, I think we can say we've done that. And on what bearing? So now we need to work out theta. Now you may note that we don't really have much in the way of figuring out theta. But if we find out that angle there, then 360 minus this angle will be our bearing. So we need to now work out this internal angle here. Okay, so I'm just going to draw a little sketch of that. Okay, because I think this diagram, as with bearings normally do, what normally happens with bearings is it gets a little messy. So we're going to work out, I'm just going to call it alpha, okay, and this here is 4.3 kilometers, and this here is 1.9 kilometers. And to work out alpha, alpha is going to be, firstly, a right angle trig, and this is opposite and adjacent, so therefore we'll be using tangent. So tan alpha is equal to 4.3 on 1.9, therefore alpha is going to be, okay, we plug in our calculator, shift divide, and go 4.3 divided by 1.9. Okay, oh, invalid syntax. There we go. On 1.9. And we close our bracket, press enter, and we know that theta is equal to 66.16 degrees. Now, what we figured out there is that chunk there. Now we know that this point here is our origin, and this here is our point B. This is where he's ended up. So picture him at this position here, and you need to tell him to walk back. We know that he has to walk back 4.7 kilometers, but we haven't told him a bearing yet. So draw a compass bearing there and go, you need to spin around that far, right? Now we now know that that is 66.16 degrees. So 360 minus this will be his bearing that he has to go, because that's a revolution. So 360 minus 66.16 equals 360 minus 66.16 is 293.84 degrees true. And that's the angle he needs to spin around on. Now it says, doesn't give, it says, we could just leave it, maybe we could just round to the nearest whole, 4 degrees true. Okay, and there's our answer.